Sorry?
Like divisor is equal to.
Yes. So Euclid division lemma is that. Oh yes, the division statement is that your dividend is equal to divisor.
Divisor into quotient. Divisor
Yes.
into quotient.
Quotient. It is quotient. So divisor into quotient plus remainder, right?
Yeah.
So this is a proven statement, right? That your dividend is divisor into quotient plus remainder. So Euclid used this statement of division, right?
Yes.
And gave a lemma. And what was the lemma? What the lemma was that you can represent any integer in the form of bq plus r. Okay.
Okay.
You can write a as bq plus r, where your r goes from 0 to b. So this is the Euclid division lemma, right?
Yes.
And Euclid division algorithm follows Euclid division lemma step by step. And then from Euclid division algorithm, you find the HCF of two numbers, right? So there is a drawback in Euclid division lemma or algorithm, because from Euclid division algorithm, you can only calculate the HCF of two numbers, right? You can't calculate the HCF of three numbers. Understood?
Yeah.
So let me write, because I have already did this in the previous classes. Just give you a quick recap. Okay. Yes. Let me put it there. So what is, you understood na lemma? What is lemma? Hello.
Yes, sir. Sorry, sir.
Okay. So Rizwan has joined. Hi Rizwan. Assalamu alaikum.
Walaikum salam.
How are you?
Fine, alhamdulillah.
So Nuha has just joined. So she is doing her first class. So I was just revising what I taught you earlier in real numbers, right? So
Okay,
this will be revision for you also. Okay. Just
Okay,
bear with me for let's say 10 minutes. Okay. So as I was telling that
Yeah.
you can let me put it. Yes. So yes. Yes. So let's say you have what is Euclid division and limit. That you can write any integer, any positive, or let's say any integer in the form of bq plus r, where your r is right. So Rizwan, I made a mistake yesterday. This will not be equal to, right? It will always be less than b, right?
Yes.
So this is, so you can write a is equals to bq plus r, where your r goes from 0 to b, right? So this is the Euclid division lemma. Understood? Noah. Noah, understood? Am I connected to internet? Hello, Noah. Can you listen Are you listening? Is she disconnected or what? Rizwan, can you listen?
Yes, sir, I can.
Oh, okay. So is she disconnected or what?
No, I rejoined now.
Okay, okay. So were you disconnected at some point?
No, because my room is an extension for internet.
Okay. Okay. So internet is fluctuating in your room.
Yeah, only sometimes, I guess.
Okay. No, no worries, no worries. So where were you with us? At what point?
Up to, it was less than 0. No, it was less than D. Yeah.
Yes. Yes. So you can write any number in this form.
Yeah.
Yes. So this is the Euclid division lemma, right? So you can write 4 as 3 into 1 plus 1, right? So this is the Euclid division lemma, right? And Rizwan, did they do 1.1 exercise yet in your class?
Which one, sir?
The exercise 1.1, the use of Euclid division algorithm.
No, sir.
They haven't done yet.
No, sir. They did 1.2, 1.3, and 1.4.
Oh, because I asked Allah and they did 1.1 exercise. So I did 1.1 exercise there.
Okay,
And
sir.
I don't know about Nuha that where they will be doing 1.1 exercise. So where are you from, Rizwan?
I am Saudi Arab.
Saudi Arab. And Nuha, where are you from?
We are in
UAE,
Huh? Same.
United Arab Emirates.
So is you. So I guess they will be following same curriculum, right? So
CBSE.
CBSE, right? So if they have skipped 1.1 exercise from Rizwan classes, so let me assume that they will skip 1.1 exercise from your school as well.
Okay, sir.
And if they do, then I will I will teach you about this Euclid division, right? So then what we did, this one, what we did in the second exercise. So I'm skipping 1.1 exercise. Is it okay with you, Nuha?
Yeah, sir, I'm already thorough with this too.
Okay, okay. So because I taught Talha the 1.1 exercise, so I don't know what curriculum they are going to follow in your school. Okay. Just tell me that they have done 1.1 exercise and I will complete that. Okay.
Okay.
Okay. So in second exercise, we did prime factorization method. And what is a prime factorization method? It states that you can write any composite numbers in the form of prime factors, right? Prime number factors. So am I correct, Rizwan?
Yes, sir.
Yes. So Nuha, can you tell me about what are the composite numbers? First, tell me
Which
about,
more
sorry,
factors?
sorry,
Which has more factors?
more factors. And what do you mean by more factors? Let's say
Like
about, yes,
2 and 4.
2 and 4. Yes, you are,
Multiples.
yes. So they have, they can be divided by themselves only and then themselves, and they can divide it by some other numbers as well, right?
Yeah.
So let's say you have a prime number which can only be divided by itself and 1, right?
Yes.
But then you have composite numbers like, let's say, 6. So this 6 can be divided by 1,
3,
2,
2.
yes, and
1.
6, right? So this has these factors. So that's why it is a composite number. But let's say you have 7. This can be divided only by 1 and 7. So this is a prime number,
It
right?
is not. Yeah.
Yes, yes. So this is a prime, right? So you already know about prime numbers and composite numbers, right? So we can write any composite number in the form of prime factor. Let's say I give you an example of 6. So we can write 6 as what? 2 into 3. So these are prime numbers, right?
Yes, sir.
So this is the prime factorization method. And what purpose does it serve? So this is used to calculate, again, the HCF and then LCM also, right? So this is used to calculate the HCF and LCM of multiple numbers, right? Okay.
Okay, sir.
And how do you calculate the HCF and LCM of two numbers? Let's say you have 18 and 12, right? So you do the prime factorization of 18. So prime factorization of 18 will be what? 2 into 9, right? 3 into 3. So this will be what? 2, 3 into 3, which will be 2, 3 square. Rizwan, I'm doing a quick revision, so just bear with me, okay? If that's okay with you. Okay, Rizwan, any problem or?
No, sir, no.
Oh, thank you, Rizwan. So 12, right? So 12, you can write 2, 6, 2, 3, right? So this is 2 into 2 into 3. So 2 square into 3, right, Nuha?
Yes, sir.
So what is the prime factorization of 18? It is 2 into 3 square,
3 into
right? Yes. And what is the prime factorization of 12? It is 2 square into 3, right? So to calculate the HCF with the prime factorization method, uh, so what you do is that, what is the common here? So 2's and 3's are common, right?
Yes.
So 2 and 2 square. And what is the lowest power on 2? So you have 2 square and 2, 1, right? So 2 is greater than 1. So this is the lowest power, right?
Yeah.
So we take the lowest power 1, right? And for 3 square and 3, what is the lowest power? This one, na?
Yeah.
So this one.
3, 1.
So this will be what? 6. So to take the HCF, we take what? We take lowest common powers, right? Lowest power of common numbers, I should write. So just understand this. This is not lowest common power, but the lowest power on common numbers, right? And for the case of LCM, what do? You take the highest power, right? So 2 square for the common and 3 square, right? And if there were some numbers, let's say A or let's say B, C, D, right? So this would have been A, the rest one, the rest. Okay. So in LCM, we take what? We take
Highest.
power of common numbers, right? And then the rest numbers. Understood?
Yes, sir.
So let me do the third exercise because I have completed the second exercise, but I have done the theory part. So I will do this exercise with you, Nuha, in the next class. So please join 10 minutes earlier, and then we'll complete this second exercise, right?
Okay, sir.
Because Rizwan will be skeptical that
Sir,
why. Okay. So I don't want to waste the time of Rizwan. Okay, that's why. That's why. Okay, if it's okay with you, Noah.
Yes, sir.
Okay. So
Sir, you can continue with the regular class because I will revise myself. Yeah.
no. I will do the revision. No worries. I will.
No, no, it's okay because I already I already finished off chapter before my school starts. Yeah.
Okay. So it was done in your school already,
No, it was not done in my school, but
but
it was
you
there.
did. Acha, you
Yeah,
did
from
with yourself. Okay. So self-study.
YouTube channels.
Okay. Nice. Okay. So let's do the third exercise. But I will do a revision of this regardless. Okay. And I will ask that what you have done. Okay. So,
Okay.
so irrational numbers. So third exercise is about irrational numbers. Let me change the color. So yes. So first, to understand about the rational numbers, you already know about the rational numbers from your earlier classes, right? So what is a rational number? Rational number are those numbers which can be written in the form of P by Q, right? Where your Q is not equals to 0 and P and Q doesn't have are not co-prime numbers, right? Doesn't have, are not a co-prime numbers. Yeah, doesn't have a common number, right? So this is the definition of a rational number, right? And before we do the irrational numbers, so there is a theorem. Okay, so just remember this theorem. Theorem is that if, let's say, a square is a factor of p, right? Then a is also a factor of p. Understood? Any doubt in this theorem?
No, no, sir.
So let's say what should I say? 16. So let's say 2 square a divides 16, right? 2 square is what? 4. So 4 divides 16, right? So 2 should also divide 16. So this is the theorem. Understood? Understood?
Yes, sir.
So is Rizwan, are you with us?
Yes, sir. Listening.
Okay. So now we have to prove first that, let's say we have to prove root 2 is an irrational number. Okay, so we have to prove this. So what we do is that we use reductio ad absurdum method. So in this method, what we do is that we assume the opposite. Okay. So we want to prove that root 2 is an irrational number. So what we will assume?
Assume it's a rational number.
Yes. So we will assume that root 2 is a rational number, right? So
Yes, sir.
we will assume the opposite. So let's say we assume that. So this is a proof. So let's assume that root 2 is a rational number, right? So we can write root 2 as p by q, right?
Yes, sir.
So now let's put q in here, right? So we put let's say, so we put q here. So this will be what? Root 2q is equals to p, right? Now we square both sides. So squaring both sides, right? So when we square both sides, what we will get? It will be 2q square equals to p square, right? Now we see that this doesn't have a common number other than 1, right? So when we assume that root 2 is a rational number, so this doesn't have a common number other than 1, right?
Yes, sir.
So from here, you see that P2 is a factor of P square, right? So P square has a factor of 2, right? So P will also have a factor of 2, right?
Yes.
So from here, we apply the previous theorem and say that P square is divisible by 2, right? So P will also be divisible by 2, right? Any problem in doing that?
No, sir.
No.
So we can write P as something 2m, right? Any problem in that?
No, sir.
Yes. So now we take the square in here. So taking squaring both sides again. Right. So this will be what? P square will be what? 4m square, right? Understood?
Yes, sir.
So let's say this is equation 1. And this will be what? So P square, the value of P square is 4m square, right? And we have P square here, right? Right.
Yes, sir.
So we will put the value of P square from here to equation 1, right? So let's say this is equation 2. So we will put the value of P square in there. So what we will get? Now putting the value of P square in equation 1. Okay. So what we will get? We will get 2q square equals to 4m square, right? So this will cancel out. So this will be 2. Okay. Understood. So we can write q square is equals to 2m square. So you can see that 2 is a factor of q square, right?
Yes,
Right.
sir.
So let's say, so we can say that q square is divisible by 2, right? Which means that q is divisible by 2, right? Right.
Yes, sir.
So q is a factor of 2, okay, and p is a factor of 2, okay, right? So they have a common factor 2 here, but this is not the definition of a rational number. This should be co-prime numbers. Okay, co-prime meaning that they don't have a common factor, right? Understood?
Yes, sir.
So firstly, we assume that P and Q are co-prime, right? We assume that P and Q are co-prime. And then with our assumption, we found out that P and Q have a common factor, which is 2. So which means that our assumption is wrong. So from we see that P and Q are not co-prime. Therefore, our assumption is wrong, right?
Yes, sir.
So that is why root 2 is an irrational number. Understood? Any doubt?
No, sir.
Okay. So this is the method that I was talking about, that you first assume that it is a rational number, okay, and then you solve it, and then you found out that this has some other common factors, okay. So that's why you say that your assumption is wrong, and the opposite of your assumption is true. Understood? Understood? Any doubts?
No, sir.
So similar case with root 3. Okay. So let's say just quickly tell you the key idea, that we assume that root 3 is P by Q, where P and Q are co-prime. Okay. So we write root 3Q into P, and this will be what? 3Q P square. Sorry. Right. So P square is factor of 3. So P is factor of 3, right? And then we write P as some 3m. So P square is what? 9m square, right? So you put P square value here. So you get what? 3 square Q square is 9m square. So you get 3m square, right? So again, you write Q square is factor of 3. So Q is factor of 3, right? So you again get 2 common numbers from your assumption. So that's why your assumption is wrong, and root 3 is an irrational number. So understood the pattern, the idea here.
Yes, sir.
Okay, so this was the third exercise, and the other part of this exercise is what? That that the irrational numbers are the irrational are what? Non-terminating, right? Non-terminating meaning, let's say 22, not 22, uh, let's say 0.347 and so on, so on. So this is a non-terminating number, right?
Yeah.
Yes, sir.
And non-terminating and non-repeating. Okay. So this is a rational number, an example of a rational number. Understood?
Yes, sir.
Okay. And the other part is that, so let's say you have a rational number. You have a rational number, which is what? In the form of 2m and 5n, right? So we can say that this number, whenever you have a 2m 5n combination, so this will be a terminating number, right? Understood?
Yes, sir.
Because whenever you have a division of, let's say, whenever you have a division of 10 or 100 or 1000, that multiple will have a terminating number, that division. Let's say you have 1 by 10. So this is 0.1. Okay, so this ends here. Let's say you have 1 by 240. So there is a 0, right? So this will be a terminating, not 24. 1000 or 100. So this will be what? 0.01, right? So whenever you have a combination of 2 into 5, or this is what? 2 square into 5 square, right? Understood?
Yes, sir.
So whenever you have a combination of 2m power of m and 5n only, right? Only. Then that in the denominator, then that fraction is terminating. Okay. So by just looking at the prime factorization of the denominator, you can tell that fraction is terminating or not. Understood? Any doubt in that?
No, sir.
So let's just say I write like this. I say 74895, something like this. And I write 2 cube into 527, right? So without, yeah?
Terminating.
Yes. So without actually dividing this troublesome division, without division, you can tell that this is a terminating, right? Without actually dividing. You don't have to use actual division, right?
Yeah.
Okay. And and whenever you have something like let's say 3 here. So you have a number in the denominator which have prime numbers other than 2 and 5, right? Right.
Yes, sir.
So this will not be terminating. Okay, so this will not terminating. Okay, understood.
Yes, sir.
Okay, so this was all about the third and fourth exercise, I guess. So let's do some exercise question, and that will make it more clear to understand. Okay. So Rizwan, did you solve the other questions?
Yes, sir.
So what was the answer of this question?
The seventh one.
The seventh one, right?
Yes, sir.
What did you find?
36 minutes.
Yes, 36 minutes. You calculated the LCM, right?
Yes, sir.
Right. So right answer. Okay. Oh. Yes. So this question you can do, right?
Yes, sir.
So what is the trick here? That we will assume,
Assuming it is a rational number.
yes, so we will assume that root 5 is a rational number, right?
Yes,
And
sir.
then we can write root 5 as p by,
P by Q.
and this doesn't have a common factor other than 1, right? So
Yes,
this
sir.
will be what? So root 5q is p. So we will square it. So this will be what? 5q square, p square. So p square has a factor of 5. So p has a factor of 5, right?
Yes, sir.
So if p has a factor of 5, then we can write p as 5 sum m, right? And then we will square. So p
Squaring
square,
both sides, then
yes. So this will be 25 m square, right? And then we will
Yes.
put this value here. So this will be what? 5q square, 25 m square, right? So
yes, sir.
this cancels. So q square has a factor of 5.
Equal to 5m square.
So q is factor of 5, right? So we
Yes.
found, so we will find that p and q has a common factor other than 1, which is 5. So that will make our assumption wrong. So that is
No.
how your root 5 is an irrational.
Irrational.
Okay. So understood this question? Nuha, any doubt?
No, sir.
Okay. So let's do this second one. Right. To do the second question, we already know that root 5 is an irrational number. Okay. We already know root 5 is an irrational number. Okay. So
Yes,
we
sir.
will assume that 3 plus 2 root 5
It's
is
irrational. It's rational.
a rational number. Right. So we can write 3 plus 2 root 5 as p by q, right?
Yes, sir.
And
Transposing.
What?
Transposing into another set.
Yes. So we will move this 3 in here. So this will be what? P by q minus 3, right? and we will take the LCM. So this will be what? P minus 3Q by Q, right? And then 2 will go in the denominator. So 2Q, right?
Yes, sir.
So in the right side, we have a rational number,
Left side irrational.
and the left side is irrational. So our assumption is wrong, right?
Both cannot be equal. Yes, sir.
Yes, they are not equal. So our assumption is wrong. So this is an irrational. Understood?
Yes, sir.
So this is how. Yeah, did they complete the third exercise? This one in your school?
1.3. Yes, sir.
Oh, that is why you know the answer, right? Okay.
Yes, sir.
Okay, okay. Okay. So you understand, na? This one.
Yes, sir. I understand.
Okay. Okay. Nuha, is there any question, any doubt?
No, sir.
Okay. So this chapter will be done very quickly because they have only the third exercise, or you only have the third exercise, or you have
Both one also we have, sir.
the fourth one. Acha, I did the fourth one theory. Okay.
Yes, sir.
So prove that following are irrational. So this is easy, right?
Yes.
How will you prove that 7 root 5 is irrational? Simple, na?
Supposing.
Yes, you assume 7 root 5 P by Q, right?
Yes, sir.
So root 5 is P by 7Q. This
Yes,
is rational.
And for root 5 is irrational.
So our assumption wrong.
Yes, sir.
So just we quickly with a flash we completed the third exercise. Any doubt, Nuha?
No, sir.
Okay. So let's just move on to the last exercise. Okay. So yes, so this was the question I was talking about. So without actually performing the long division, right? State whether the following rational numbers will have a terminating decimal expansion or non-terminating, repeating decimal expansion, right?
Yes,
Yes,
sir.
sir.
So just we will we will check the denominators, right? So 3125. We will check 3125. What is the prime factorization here? So this is what? Let's say we can only say we can already see that this doesn't have a factor of 2, right?
Yeah, because the last number is odd.
Yes. So this will be at non-terminating or terminating one.
Terminating.
Terminating because these have only 5, right? Factor of something 5. 5n. This doesn't have.
Yes, sir. But my sir told that the power of 2 will be 0. In that way, we can prove that it is an terminating.
Okay.
That power of 2 will be 0. That is equal to 1. That
Right.
doesn't have value.
Right. Okay. Yes. So yes. Yes, you are right. So 3125 is yes. 2m and power should be yes. So n and m are non-negative, so this could be 0, right? So this is a terminating one, right? But
Yes, sir.
is this yes? So they are asking about which have a terminating decimal expansion or a non-terminating repeating. Yes. So this is a terminating, right? And what about 7 by 8?
Terminating.
Yes, this will also be because 5 to the power 0, right? As you
Yes, sir.
So this is a terminating one, right? And what about 455? Four 55.
Not
Yes, this will be non-terminating and repeating, right?
yes, sir.
Because this has a factor other than
Five.
2 and 5, right?
It has 13 and 7.
Yes, so this is a non-terminating, right? And what about 1600? As you can already see that it is a factor of what? 2 and 5 only, right? So this is a terminating. Understood?
Yes, sir.
Yeah.
So let's just calculate. Okay. Now, yes. So you do the rest ones, and we move on to the second question. Yes. So in second question, they are asking about write down the decimal expansion, right? And how do you calculate the decimal expansion? You don't divide, right? You don't divide the number. You actually calculate, you match the power of with power of 2, right? So if this is mn, then you multiply in such a way that you get 5n and then 2n, right? M, right?
Yes, sir.
So let's say you have 3125, which is what? 5, 6, 2, 5. So this is 5, 1, 2, 5. So this is what? So this is right. So this is what? So this is 13 by 1, 2, 3, 4, 5. 5 to the power 5. Right. Understood? Understood.
Yes, sir.
Now to calculate the decimal expansion, what we do is that it has 5 to the power 5, right? So we will multiply it with what? 2 to the power 5, right? Understood?
Yes, sir.
And then in the numerator, we also multiply because we have divided with 2 to the power 5. So we will multiply it with 2 to the power 5. Okay. Understood?
Yes.
So this will be what? This is 10, 0, 0. How many zeros? 10 to the power 5, right? So 50, right? Understood? And this will be what? 2 to the power is 5 is what? 2, 4, 8, 16, 32, 2, then 4, then let's multiply into 13. So this is what? 32 into 13. So, right. Understood?
Yes, sir.
Yes.
So this will be what? 416. So the decimal expansion will be what? 0.00.
0.00416.
Right. So without actually doing the division. Yes, that's the, so we have verified that it is a terminating one, right? This one, right?
Yes, sir.
So without actually doing the division, you can calculate the decimal expansion, right? So please calculate the decimal expansion of 17 by 8 and tell me the answer. Nuha and Rizwan, please calculate and tell me the answer.
Yes, sir.
So what did you get, Nuha? Nuha, did you get the answer?
Yes,
And what is the answer?
2125 divide 1000.
Yes. So 2125 divided by 1000, which is what? 2.125, right? And Rizwan, did you get this same answer?
Yes, sir. Yes, same.
Yes. So right answer. Okay. And so you understand, no? Let us do this. Oh no, let's do this one. This is simple. 23 by 2 cube into 5 square, right? So for what number we should multiply with here so that the numbers are equal? So what should we multiply here?
5.
Yes, 5 and 5, right? So this will be what? 1000, and this is whatever. So this is what? Right. So this is 0.11. Okay.
Yes, sir.
So this is how you calculate the decimal expansion, right? And okay, so this completes the second question. And in question 1 above, you only have to calculate which are the terminating ones. Okay. So you
Yes.
don't have to calculate the third one, the fifth one, right? And the seventh one, and the what? This eighth one. Okay. And yes, this one, right? So you don't have to calculate these numbers, which are not terminating. Okay.
Okay, sir.
So in the second question, they only want to calculate the decimal expansion of those numbers which are terminating ones, right?
Yes, sir.
Now let us move on to the third question. Okay. So the following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form of P by Q, then what can you say about the prime factors of Q? Right. Right. So this is what? This is a terminating one.
Yes, sir.
So the prime factors of third question, the part 1 of third question will be what? Prime factors of this question will be what? Only 2 and 5, right?
Yes, sir.
2 and 5. So the prime factors of this question will only be 2 and 5, right?
Yes, sir.
And what can you say about this number? Is this a rational number or not?
It's irrational.
Yes, it is an irrational number because it is first, it is not.
Non-terminating and non-repeating.
Yes, so this is an irrational number. And what about this number? So this is what? This is non-terminating.
Rational,
Yes, so this, the third is non-terminating
but
and,
repeating.
and repeating, right?
Yes, sir.
So what can you say about the prime factors?
2 and 5.
This have 2 and 5 as well as other factors, other prime numbers, right?
Okay.
Because if it had only 2 and 5, then it would have been a terminating one, right?
Yes, sir.
But this is not a terminating one. So this will have 2 and 5 as well as some other prime factors such as 7 or 3 or any other, right? So this completes the first exercise. Do you have any doubt or any question?
No, sir.
Okay. No question, right?
Sir, the second one, 0.1201. Yeah,
Yes.
the decimal is irrational, right?
Yes. So this is an irrational number, right? Right. Yes. Yes.
Oh,
So that's why we can't talk about the prime factors here, right?
yeah.
Yes. And do you have any other question?
No.
Okay, so this completes the first exercise, first chapter. And in the third, so Rizwan, have they started the third chapter?
No, sir. From tomorrow, sir.
So from tomorrow they will start the third chapter. And
Yes.
Is that equation in two variables, linear equation in two variables?
Yes, sir. Yeah.
So, okay, so as you have done the polynomials, right? So can you tell me about what will be the degree of the linear equation in two variables? What will be the degree?
2 or linear equation.
So let's say
7.
7.
1.
Yes, 1, one, because you have, let's
Linear
say,
equation.
2x plus 3y is something like 5, right? So the power will always be 1, the highest power. Because
Yes.
if you have, let's say if you have 3x square, so this will be what? A quadratic equation, right?
Yes.
So the third chapter is about linear equation. Linear equation means that the degree of the polynomial is 1, right? And two variables, meaning that it has two unknown numbers, right? So I'm giving you just glimpse of the third chapter. I will start the third chapter from the next class, and the next class will be on what? Wednesday. Is that on
Yes.
Wednesday? Okay. So we will meet in the Wednesday's class and we'll start the third chapter. So let me just give you a glimpse of the third chapter. So you have linear equation, right? Linear equation meaning that the power is 1, okay, and two variables meaning two unknown numbers, right? So to solve, and in the third chapter, you will be solving these linear equation in two variables, okay? So let's say you have a linear equation 2x plus 3y is equals to 4, and you have 3x plus 4y equals to 9, right? So to solve a linear equation in two variables, you need how many equations? Why am I asking? You haven't done the third chapter. Okay. So to solve a linear equation in two variables, you have what? Two unknowns, right? So to solve or to find two unknowns, to find two unknowns, you need two equations, right? So you will see that you will always get two equations. In the third chapter, we'll always see that there are two equations, and you would require two equations to solve the value of x and y, always. So if you have two unknowns, you will need what? You will need two equations. Okay. And if you have, let's say, three unknowns, then how many equations you will need?
Three equations.
Three equations, right? So let's say you have a linear equation in three variables. Let's say you have a linear equation like this. So 3x plus 4y plus 2z equals to, let's say, 5, right? And then to solve this equation, how many unknowns do you have?
Three.
Yes, 3. And is it a linear equation?
Yes, sir.
And why is that?
Because the highest power degree is 1.
Yes, so degree is 1. So this is a linear equation in three variables, right? And if I write 3x equals to 5, so this is a what? Is that a linear equation or not?
Yes.
So this is a linear equation in one variable, right?
Yes, sir.
So to solve, and you see that to solve x, you only need one equation, right? So you can find the value of x as 5 by 3. So to solve one equation, to solve one unknowns, you only need one equation, right? And to solve two unknowns, you will
Two
need
equations.
two equations. And similarly, to solve three equations, three unknowns,
Three
you will need
equations.
three equations. Just like they will give 3x plus 4y plus 2z equals to 5, and then they will give 2x plus 3y plus let's say 4z equals to 2, and then the third equation 2x plus 9y plus 3z equals to some 7. So you will need three equations, right? So and then you need to have a method to solve two linear equations, right? And you will learn that there are actually two methods. So first one is the substitution method. I'm writing all this in this notebook, but I will make a separate notebook of that for the third chapter.
Okay, sir.
So I'm just giving you glimpses of what will be in your third chapter. So there are two methods. Okay. So one method is what? Substitution method. And the other one is what? Cross multiplication method.